finishing this. I did a bunch of optimization. Our galaxy generation time is quite fast now. I did some work to make this point cloud generator for the universe that's kind of doing like a cosmic web, but it needs a little bit more work. And then I have a bunch of code to go over and clean up because I've been bashing on a couple problems all day today using like various different attempts to solve them. But yeah, if you notice, our last galaxy generated in less than a second. That's really good. That's definitely enough for our purposes. So we're generating in less than a second usually with no frame stalls. There's still one garbage collection hitch that I haven't figured out yet. I'm hoping that when I go to Niagara Pools, it'll fix that, but we're not going to worry about the garbage collection hitch till everything else is done. And that'll probably be the last bug we look at. Um, then I need to do like a project overview. And that's pretty much it. So like that one took 6 seconds, but I think that probably happened at the same time as the garbage collection glitch because that does occasionally happen. Or not glitch, it's just like it garbage collects and it eats way too much time doing it. Um, Obviously the density of the background gas needs to go down a bit, but we are generating our kind of cosmic web esque pattern of galaxies. Ended up just doing it with a noise generator. Our generation time is also down for our universe from like 8 seconds to like 4 seconds, which is quite good. Um, yeah, so all in all, lots of progress. At some point, I may review the volumetric method I ended up going with because it's actually really slick and took quite a bit of figuring out. We switched to a bulk insert paradigm where instead of trying to insert a point inside the generator every time a point is generated, I just have the generator keep track of its own generated data and then we submit all of that at once in a bulk insert to the tree. And the tree handles the parallelization of the bulk insert, which sped that up quite a bit. And also, it allows us to collect the results as a part of the insert, which means we no longer have to do a data fetch to get the results after we're done. We can just use. You'll notice that the node fetch is down to 0.006 seconds, and that's because of that. We don't have to go do a find on the octree anymore. You only need that for spatial queries. Uh, but yeah, we don't need that. And yeah, I'm pretty happy with it. Let's see. So if I pull up the universe material, let's go ahead and fix a couple things here. Okay, we don't need it to be this dense for one thing, and I think I turned off distortion. That's a little better. Yeah, I turned off distortion. We'll turn distortion on at like a 0.05 maybe. And that's going to camouflage like the voxels in the volume texture and provide a little bit more variance to the gas. I really like the cosmic web point cloud generator that we've got for the universe now. So there's one other thing I gotta do. I need to make it like a circular fall off instead of just going right to the edge. It needs to have radial, like exponential fall off. Okay. But yeah, it's starting to look pretty good. It's starting to run pretty good. The project's actually close to done. Once this is done, this becomes a plugin for the project that the planet's in, and then we start looking at like a solar system actor to load in into real world space instead of virtual coordinate space. And shortly after we get that up and running, we would be able to like go down, land on a planet, walk around, go into a spaceship, fly up into space, fly to a different star, go to a planet, go down, walk around, fly back into space, and then we could fly to a different galaxy, etc. Yeah, so gosh, there's so many changes this weekend. There's almost too many to count. The biggest change is that I figured out a way to asynchronously generate and load the textures without having any of it have without having to have any of it touch the game thread. And it required changing the type of texture we're using to a volume to a text 2D, and also encoding it as a pseudo volume texture. But once those things were done, um, we're able to basically make our volumetric initialization much faster. Like you can see here, it's happening in a tenth of a second. It was taking like 2 seconds. Um, but like everything's been optimized at this point. Like I've got the whole thing down to under a second. Most expensive part's still generation, but it's kind of whatever. At this point, it loads faster than you can get to it, which is the goal. So we need this to be like a radial and not a cubic pattern here. So that means we can probably go into our point cloud generator for the universe and add an additional rejection parameter. So like this is the first one. Um, we could multiply this value by some function of the radius, maybe, that the sample's at. So noise sample. So it would be the vector length of this over the vector length of this over the total radius. So the actual, it would just be universe params extent, I think. So we could also, my brain is so fried. We could also just okay, this ended up being my loop. We need one more change though. Currently, it fills cubic volume. We would like to add radial fall to our rejection check. Yeah, okay, this is what I was looking for. So we want it to bias something like this, maybe. This is scaling it to match the noise, but this is the actual point center. So I think that's what we actually want. And then yeah. So we don't need this. We can just do this. We don't need an extra assignment here. And then this again. We don't need an extra. Well, wait a second. This is 1 minus. Point center size over universe parameters extent. Okay, let's just try it. I think that's probably close. Hello. What's up, dude? I'm just trying to finish up this cosmic web point cloud generator, and then it's going to be code cleanup and review because I have made a lot of changes. I forget when I'm changing the universe, I have to rerun. But I made a bunch of optimizations. It's running pretty good now. There's probably some spaghetti that needs to be cleaned up. So basically, I'm trying to put the last little finishing touches on this. All right. How's our web look? Okay, yeah, that's better. That is better. So here's our observable universe, and then we go to any of these points. And we have different types of galaxies. Find a nice spiral. Ah, I went too fast. Not a spiral. I mean, I did make spirals the most common type, but RNG is a thing. Eventually, I'm going to add some like scanner logic to it so that we can like emit a pulse and find things that we could target, but not until after all the pieces are put together. We're still building the Legos that we need to build the end thing. Come on. Okay. There is some instability still. Uh-oh. So we have the black holes conceptually represented. I can show you, but we don't. I don't have. I don't have. I have a ray marcher that can go on a sprite that'll do like a decent black hole, but it's in the other projects. So right now, our black hole is just represented when we do our selection pruning in our galaxy generation. Any points that would get pruned will be zeroed, and then at the end they all get combined into a single point, and like so all their density gets added and all their colors get added, And so, like, this point here would represent the black hole. We would just have to make the asset to do like a black hole effect on it. Right now, it's just a particle. But, like, the way it works is so there's like a central void. Any stars that get spawned within that central void get zeroed out and added to the black hole. And then we have a variety of ways that stars can get rejected from being like generated. And if they get rejected from being generated, then it will also go into the black hole. So, like, we have the data there in our data model, we just don't have the asset for it yet. I'm trying to find, like, I'm just getting boring galaxies. I'm getting, like, boring disk galaxies. I might have, like, a fucked up ID. I bet I have a fucked up ID, object ID. If they're all giving me the same type of galaxy, it means that my object ID is probably not being properly set. Let's see. Yeah, it's another disk. Okay. Yeah, so I think we need to look at the universe generator point cloud stuff and make sure that we did not lose the unique indexing. So that's down here. Oh no, this is the header. Down here. Yeah, so where's my... Okay, yeah, that's absolutely what it is. So basically, this insert data contains a payload that goes into like a octree that stores like all the voxels and stuff. And the idea is that for this project is supposed to handle things that are bigger than you could represent in like real space. So this is for everything from like star system up, and then we'll do another like in the star system you'll navigate in like world units. Outside of the star system you navigate in like virtual coordinate units basically, and that's what this project is for. But the voxels have an ID on them, and that's going to be inside this data object ID, and it's very important because it becomes the seed for the galaxy generator for that voxel. So the issue here is that we weren't setting this to a unique value. So they all had the same ID, so they were all generating the same galaxy. Now, when I build this, they'll generate different galaxies. So that's... I'm going to do, at some point, I'm going to do a breakdown of all the stuff that went into making this actually work. Because there's quite a bit, and a lot of it is pretty interesting. I'm kind of getting my thoughts together on that. There's like parallax is a big one. This weekend I came up with a way to async bake volume textures, which means that like the volume texture I generate for the volumetric can be generated off the game thread and maps to the texture off the game thread. So that removed a big like performance hitch basically. All right, so this is this. Oh, wait. It's the universe generator that I just changed. So I have to restart the project because the universe only gets generated once. But yeah, like so I ended up going to something called a pseudo volume texture, which is a 2D texture and not a 3D texture. I was generating volume textures, but there's a methodology I found of like async baking the texture data, and it uses a bunch of RHI hooks, and those hooks aren't there for volume textures, so there's like no way to do it for a 3D texture. But what you can do is change the way you encode the texture. So like say you're doing a 256 by 256 by 256 volume texture. That has the same number of pixels as a 4096 by 4096 2D texture. So you can encode all the data into a 2D texture in slices, like 16 by 16 grid of 256 by 256 slices. And that gives you your volumetric data, but in a 2D texture. Then you just have to change the way you sample it a little bit to get it in back into 3D in your material. And with those two things combined, I could generate the volume textures for the gas off the game thread entirely. And it just massively, like, it saves like a second worth of loading time. Now, this weekend I've been kind of chasing optimization with the idea being you want them to load in before you get to the point where the sprite for it would disappear. Okay, so still just a disk there, but I'm pretty sure it was slightly different, so let's find out. Come on. Yeah, there we go. Yeah, that's like an irregular cluster. So yeah, now we have different galaxy types. If I eventually I'll find a nice spiral. That's another irregular glob. Oops, oopsie, too fast. I'll just go to a different one. So there's still a hitch, which you're seeing here, and I believe it's linked to garbage collection. So I'm gonna have to figure out something about that. But I've kind of been pushing that until all the spawning was completely optimized. And I figure like get the spawn in working smoothly, which it pretty much is now. See, this is another garbage collection hitch, I think. And then we'll try to figure out like what's going on with the garbage collection hitch. But yeah, there we found a nice spiral. Um, but I've been like kind of bashing on the code for a little bit now, and um, it's kind of messy because I've just been like, will this work? No. Will this work? No. Will this work? No. Oh, I found something that works. I haven't cleaned it up from the other four things I tried yet. So I need to kind of. Oh, that's a nice one. I need to kind of do a cleanup pass on all the files that I've touched. But I do have this working, so let's go ahead and commit a baseline. Could you not put it in a while loop to get rid of garbage collection? Maybe. I don't know. Like I haven't looked into it at all. I think I'm gonna have to do some like manual. I think it may be related to the fact that I'm generating like really large data arrays, like in quite a few of them. And so when you destroy that galaxy actor, you're losing like several several like multiple different million entry arrays of various different stuff, and maybe it needs to handle that a little bit better. So you can bake a volume in Unreal. You can do like I've figured out a lot over the past couple weeks of working on the like volume renderer for this. That's doing like the gas for the galaxy and for the universe level. Um, oh man, that cosmic web looks pretty good. I like it. Like this is using a fast noise formula. Cool. That's like a tight spiral. It's a fat one. Um, I can tell you like if you want to like so I am generating volume textures and like I'm doing it in the C++ side and fully encoding them at runtime. to volume texture that can be then put on a material, which is how the gas works. Um, it did like it was basically a combination of two different blogs, blog posts. There's I have to remember their names. There's two guys. I think Ryan Brooks was one, and he did the stuff on like the pseudo volume texture creation, and then hang on, let me check something here. It's like efficient runtime texture generation. There it was Peter Leontev. So I found this article. Efficient construction of textures is the name of it, and it uses this method of building the texture with RHI calls asynchronously. It calls async create texture 2D, and you can call that off the game thread, and then it calls update texture reference. So basically, you build the data into the graphics card directly, and then you just swap a pointer instead of having to do like a full mem copy of the data into the texture. You just basically trade the texture data pointer in the texture to your new data that you did with this part. So like you can build your texture with a MIP one by one. So it's just like a one by one texture. You can build that on the game thread like that, and that'll be pretty much instant. And then you can bake your texture asynchronously, and then finally you can swap out the pointer on the game thread again, or on the render thread. You swap the pointer out to the data that you just did, and then after you've done that, you basically fully async loaded a texture that you generated at runtime. So it's this combined with right volume, pseudo volume. Some of it from this. Um, but basically, we bake it. Did you put in a while loop? So you bake it in. I'm trying to remember what it was. Like okay, we'll do this. Paint. So basically, if I have a 256 by 256 volume texture, like a 256 cube texture, it turns into a 4K texture, and it works like this. You do a block, you do a block, and this would be like 256 squared, right? And it turns out that there's 16 of these on each axis. 16 times 16 is 256. So each of these slices is like a z-axis slice of the volume, and you just go like top to bottom. So this would be the very top slice, this would be the very bottom slice, or however it's encoded, and you can bake that into a 2D texture. And the reason you have to bake this into a pseudo texture instead of a volume texture is because that command he uses to generate the texture in let me find it. This call does not exist for creating a 3D texture. So you cannot use this to create a 3D texture, only a 2D texture. So basically, I moved away from volume textures entirely to that pseudo volume format, so that I can make use of this call to encode it and not like block the game thread while it was baking what amounts to a 4K texture, and that stops it from lagging when it has to generate that texture. And so I think the only other real bad spike of lag I have is that garbage collection issue, which I will chase down. I just want to get everything buttoned up and chase down the garbage collection issue last, because like if I'm doing more dev, I could just introduce more garbage collection issues potentially. I would rather fix it all once at the end. But yeah, so there's a nice one. And it's cool because like anywhere you go in this becomes your night sky, right? And because it's all parallax driven, like I can make it to where I'm not moving anymore. This is just my night sky now. Or I could make it to where I'm just cruising around at like interstellar speed and everything's moving correctly with like precision. And all of these points are also in a octree, so we can do like proximity scanning to like load in stuff, which is how the galaxies get loaded in. But yeah, so or we could go to like intergalactic speeds. That's kind of nice. And then the color shifting like that, I just wanted the nights like the universe backdrop to be slightly different depending on where you're at. And I haven't figured out a better way to do that than just like introducing kind of random color variations based on your position within the universe. Ooh, that's a nice one. Fancy. It's all good, dude. Man, that looks fucking sick. Haha. Very cool. Oh, there's the hitch. So we're gonna want to figure out a better way to kind of get the colors from this. I'm thinking the accumulated color for the nodes might be interesting. I am curious what would happen if we kind of incorporated that in because we have that information. This volume texture is great. Or this noise formula. It it looks like a cosmic web. Quite happy with that. All right, I'm pretty happy with this. So I'm going to start. Um, what do I need to do here? I need to start. Probably a code cleanup pass would be prudent. Actually, let's commit this as a baseline. Save this. Let's see. Okay, so here we go. All right, bunch of changes. All right. New baseline working. Okay. So the last thing I think we need to do is basically do a pretty broad scale cleanup pass. Um, I'm probably going to start removing point cloud generators that I'm no longer using. So like all of this is valid. These are not valid anymore. This is valid. Everything, like, we're not using any of the stuff. Okay, this is the configuration for the for RAM Factory, so it has a bunch of like hard coded shit. Okay, there we go. So burst noise generator I want to keep because I haven't used it yet. But I may just comment all these out. This may be better to use. Let's just move them for now, I guess. No sense completely getting rid of them. And then we can wrap them in like a pragma. So, Prime Factory. There we go. And then we can, yeah, 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 yeah. Okay. Yeah, this will help a lot with making it easier to get around in. This class is just really hard to navigate around in because it has like a lot in it. So we're just getting a little organized here. Oops. Oh, no, 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 no. What? What the fuck was that? All right, nice. There's our class. 4 lines of code. It's only, 2,000, 2,200 lines of code. But it's all collapsed, and we have little navigable sections. Love it. Okay, so just getting organized is worth it. Um, Point cloud generator head. So this is fine, but we should honestly change all of our generators from generating data into the octree to generating them into its own buffer, like we did with the new stuff, because all the methodology here is kind of defunct. Okay, so cleanup pass, galaxy generator, generate data changed a bit, I think. Clean up all this commented out spaghetti. Um, this step check. I'm just thinking. Radius. They get accumulated into. They get accumulated into the black hole, and then the original star is configured. Be ignored. Insert time. Their data gets accumulated in the black hole. Original star is configured to be ignored in bulk insert. Okay, that's good. Do this. This should be allowed to be the accumulated density max gas accumulation much could type calculate approx radius based density. Okay, this is all done. Just cleaning out stuff that we ended up not using. Okay. Let's actually move this down here. Okay. So I think this is fine. This is the top level generate data. I don't want to review right now the like subcomponents and how they work. There's a massive amount of code there to go over. This, we can get rid of this. We didn't end up using it. We can get rid of these. We can get rid of this. We can get rid of this. Okay, those are lies. This is our our cosmic web here. Don't need this yet. Okay, so far so good. Let's we're not proceduralizing the universe yet. We're hand tuning that, but we do proceduralize the galaxy generation. So I'm gonna clip all these and put them lower. They really don't matter that much anymore. It's these that really are. Let's do this. Universe. Param. Jerry constructor. Okay. That's looking pretty good. Okay, so I think we're good. Point cloud generator and point cloud generator. Pretty satisfied here. Now, next up we probably want to do a side-by-side with Galaxy Actor and Universe Actor C++. Because they're actually pretty similar. So, we need to make sure that all the best improvements that we made to each one is shared, right? Universe Actor, Galaxy Actor. Yeah, so we actually don't need this assignment. It's just a pointer. So it basically saves pretty much no performance, but even so, just for the sake of consistency. Okay. Yeah, this is fine. We can get rid of this. We can get rid of this. I don't think we need this anymore. We're not using a volume texture. What Is this asset registry module for? Okay, need this. Need this. I think I need this. Okay, that's the method that we got rid of. So we need to make sure this still runs. Our universe generation time is also faster now. Not like a ton faster, but it is faster. It was taking like 10 to 14. Although that one took a pretty long time, to be fair. Oop, zoomed through it. Alright, so everything seems to be working, so I'm happy with that removal. Uh, let's keep investigating. You can leave it running. Get rid of all these. Want as much vertical space as possible. Okay. So all of this makes sense because we need the class so that we can generate these. We don't need that here. This is good. Could almost be abstracted into a base class, but no big deal. Make an octree. Switch to async task. We want these to be mirror images as much as possible. It makes it easier if they can keep in sync. Um, can add comment in replay video quickly. Uh, uh, fine. This is fine. Total duration is fine. Okay, that's great. Try to clean up. Is identical. Okay, so we're going to collapse the methods that we've reviewed. Mark destroying is fine. Initialize data. We leave this to do. That's fine. This. Okay. So, initialize data. Think it looks pretty good. Then we do our bulk insert. Okay, that all looks good. Fetch data. We should probably change the name of this, I think. We do not need to. This isn't so much fetching data as it is to um, populate the Niagara data. Oh. Oh god, this is way slower. Um, point nodes. Yeah, we don't need this. It's just point nodes, point nodes, point nodes, point nodes, point nodes. But we're still doing the fetch. Oh my god. That's the most expensive thing we could have done there. Okay, we do that. I like the space here. We build out our arrays. Okay, now let's rename this. This will be populate Niagara arrays. population took like seconds. So the reason this is changing is because we're not fetching data anymore. This used to be like fetching all the populated nodes from the octree, and in the case of the universe sector, it still was. But we just cut that, and that's a huge performance boost. So that's going to make this like a quarter to a half a second faster, maybe even more. Okay, so this one is fine. It's just directly using point nodes. And this one is fine now too. It's just directly using point nodes. I think these are fine. Okay, initialize volumetric. We may not actually need this part, but am I passing noise in anywhere? Yeah, that's what I thought. I don't use this anymore. If I delete that, do I get errors? No. Okay, perfect. Pseudo volume texture, texture data. Upscale pseudo volume density. Yes, so we don't need this. I actually want this whole block. And we're just gonna drop it right here. And then get rid of this. Looks good, looks good. Promises. Begin. Source start. Create a dynamic material instance. That's fine. This is fine. Volumetric component. Check. We don't need the visibility stuff for that. Set static mesh. Set world scale 3D. Attach to component. Add material. Sort priority. How does work? If one is 0 and the other is 1, which display waves. Okay. Okay. Looks good. Register, register. Value. We don't need this anymore. All right, we get rid of this. And that means we don't need this either in either place. And then, yep, and we fixed this. Alright, looks about identical. Rigging up the resolution so that it automatically determines the insertion depth instead of having to manually set two things would be nice. Initialize Niagara. Okay, start time. Start time. We'll go ahead and make the spacing the same. Spin up an async task. Future looks literally the same. Sort priority. System fix sounds. Max extent is needed on the Galaxy version, I guess. Sets all the interface like this if we ever want to use the rotation, which we might, because like it would be nice if we could make our universe level sprites not automatically face the camera, but instead align with the galaxy's tilt, which would be pretty cool. Um, but we're not too worried about it yet. All right, so this looks fine. Looks fine. Okay, all the Spawn Galaxy stuff should not have changed, so that's good. Begin play is good. Tick is good. Alright, so these are reviewed. Close you. Close you. We're not worrying too much about headers right now. Data types. Okay. And then it may be that having this like this would be better. Yeah, I think if we use this through a setter, then we wouldn't have to calculate this every time. So anytime we're inserting, we have to do this conversion. So if we're inserting 500,000 times, that would be 3 rounds. I mean, probably not too expensive. Um, let's add a to do for it. To do. Use overloaded setter to correctly set. Position. Then we would do these rounding actions every time we need to insert point data. There's a bit of overhead. Just identify this as a place that we can do. We still are not making effective use of this extra data. Investigate ways we could encode extra utility. Okay. Other than that, these look fine. Alright, so next up is going to be the Octree, which also had a bunch of changes. Alright, reviewing this. Octree nodes, index, depth, parent, children, Center extent data. It has a constructor and a child constructor. Looks fine. About what I would expect. Okay. Root extent. This can default to 0. Just changing these orders a bit. And all references. I want to see if I'm using both of these. More to this. I'm not using it. Insert. No, not like this. Like this. All right, let's do cleanup pass here because this is all new stuff. it actually looks pretty good. Using a pointer as a map fucking key is brilliant. Pretty sick. Okay, that looks good. I still don't 100% know what this is doing. It's doing some kind of bit shifting shenanigans, but it seems to work, so we'll leave it. Yep, that basically initializes our bulk insert array, and then this is our insert that is used from bulk, which is going to probably end up being the only way that we interact with the insert anyway, so we might just get rid of the other insert position. But it's currently used in a bunch of our example point cloud generators, so we'd have to fix that. Thinking. Am I using leaf extent? I don't think so. Yeah, so like I don't use this, and if we don't use this, we don't need it. Don't have to do that. Ignore inserts into zero, zero, zero. Ignore typeless. Okay, great. So that's our first thing. Oops. Nope. Not like that. Yeah, I think I want to get rid of that insert position. Maybe it's okay. This is just. This is just hitting this one. But again, like we might be able to get rid of this as well because I'm not seeing any other usages. See if it builds. Okay, builds. Let's try to run it again. Should get to see the fetch speed gains here. Whenever it checks this universe, which is taking quite a while actually. 20 seconds? Excuse me? Why did it take so goddamn long? I didn't change anything. Okay, it's working, so we're good. So where was I? We were looking through. We deleted the old insert, collect leaf nodes, collect populated nodes, or internal helper methods, get leaf, get populated. these are fine. If the density is less than 0, it doesn't pass. If the depth is out of range, it doesn't pass. If the depth is... Oh, if the depth is out of range of the min or the max depth, it doesn't pass. We could probably merge those into one. Then if the type filter is not -1 and the type ID is not equal to the type filter, it doesn't pass, otherwise it passes. Seems fine to me. Get leaf nodes, get populated nodes, collect nodes in range. Seems pretty solid to me. Now, how about the texture processing stuff? So we got rid of this, generate volume data from noise, the original version. And we switched to using this, which takes the volume nodes in. What do I need from the octree? Extent and depth max density. I mean, that's fine. Are there any references to this anymore? Don't think there should be. Okay. We kill it. Kill it. Okay. I'm gonna leave the logs in for now. We'll remove them at the very end. I like doing my parallel fours like this. And there's a reason I do. It's because then if I ever need to debug it with a equivalent for loop, I can comment out this line and this line, and I've commented out the entire parallel for, and instead of having to do multiple lines. This looks fine. Upscale. Okay, so this is the stuff that I was talking about. Um, like basically we generate our volume texture at a certain level of the octree, then we upscale it. This is the upscale step. But I think this is all just math, so this should be fine. And then finally, we have this generate volume texture from map data, but we shouldn't be using this anymore. Or this. just unnecessary calculations. We're always going to 4096 by 4096. This is never going to need to be in an N64, I don't think, because 4096 squared, like all of this can be hard coded because we're always going to 256 volume texture. So 4096 squared is 16. Times 4. 67,108,864. 67,108,864. Two D res. Bytes per voxel, tiles per side. Okay, so we need to figure out. This is used in a few places. Okay, great. And then this is used in a few places. Okay, fine. And then this is used here. And then this is fine. And that also means this can just be it. Okay, that has to stay variable. Okay, bring the logs back in. Upscale to pseudo volume. Okay, looks great. Okay. Again, this can just be hard coded. Um, Something like this. This can be N32 again. Create the pseudo volume texture. Okay, it looks good. Tony. Okay. Pragma. Okay. Why is it upset with that? Pragma region. My eyes crisscrossing. What? Okay, pick that up. I must have dyslexia. Probably acting up. Okay. Cleaning up, cleaning up, cleaning up, cleaning up. Think it's looking good. Um, do I have anything else that we have touched that we need to look at? No, I don't think so. We may be able to get rid of like sparse voxel actor unless I'm extending from it. Which if I was, it would be like galaxy actor, but it's just extending from A actor. Sparse voxel actor may be able to go. Um, I guess it's good as an example of like our first initial attempt at this, but like it's really far behind our galaxy and universe actor at this point. We need to update our ray march volume and pseudo volume HLSLs um, to match our code, current shader code. Ban these fucking bots. Okay. Um, okay, this is a problem that we can fix. I think this actually needs to be set to camera on get camera. Um. Oh, it's old. No wonder. I'm looking at the sparse voxel actor. I was like, that's not right, but I'm sure. No, I'm doing it wrong. Uh, okay. I'm pretty sure I should be getting player camera here instead of the pawn location. Camera location, pawn location. Okay. So we're going to change the way we get this value here and in the universe controller. And make sure this is all cool. Tear it down. Oh my gosh. Okay, so cleanup pass. I think we have successfully completed the cleanup pass. We're very close to a baseline. Like, we're almost done with this. Is it gonna manage to stop the sim? Alright, let's try it. Seems to work just fine. Universe Gen was 5 seconds, which is absolutely acceptable since we only have to do it once at the very start. Oh, I see. There's an issue with that. Well, that is interesting. Why is there an offset here? It's really chugging. That is quite interesting. Vector, camlock. This is quite interesting. So is this different? I think this is different. Camlock. Oops. Cam. Let's try this. Before I go back to the way it was, that's probably why I fiddled with it to make it the pawn location, but I bet it's because the camera's viewpoint is what our actual frame of reference is, and it's probably slightly different than the camera location, which would definitely give us like a flawed parallax offset. But because we like manually jammed our camera into the exact same location as our character start so that the viewpoint overlapped, it works in the other mode. But if we do this and if we get this right, then we would be able to have like the camera on a spring arm, which we're gonna need for any kind of like spaceship that we would make. So it is important that we get this to work with the camera instead of the pawn location. Otherwise, we would have to figure out some kind of fly by night deal. All right, let's try. We'll go to this one. No, it's even further off. What the fuck? is that the case? When I place in the universe actor, hang on. When I place the galaxy, where is my base position set from? Galaxy spawn position. In reference position. Find all references. This is why. This is why. So right here, we do owner, camera, manager, camera. Okay, and we have one more issue. Right here, the galaxy is spawned relative to the their location, but if parallax is based on camera location, then spawn will also need to be relative to the camera. And then we can probably go back to the way we were doing it here. And okay. Will this fix our spawn? I think it does. I think that is the issue because we're spawning relative to the player, but calculating parallax relative to the camera would definitely cause some mismatching. But being able to have our camera on a spring arm is going to be pretty important. Okay, we destroy it. We spawn it. Spawn? Fuck me. Why is it spawning off center? Does it have to do with the proximity tracker? Universe actor. Right here, too. There it is. Nope. Well, where the hell did it go then? Alright, we gotta figure out where this thing went off to. Hang on. Spawn another one. Spawns in. It's nowhere to be found there. Okay, that's not right. Oh no, this is correct. Okay, that's reference position. So spawn galaxy. Alright, and then that goes into universe actor and invokes spawn galaxy. Okay, that's putting its like current world position, player to node, reference position. when I spawn my galaxies using... I did commit all this, right? Oh fuck, I didn't. I did. Okay, I'm getting camera bombs. Using when I use cam position as my parallax frame of reference, galaxies are spawning in offset somewhat from the the particle parent node. Perfect overlap. Something's not quite. Somewhere here is an example of parallax code now. As well as my spawn galaxy. Finally, where I invoke spawn galaxy. Let's see if it can give me something to look into. Give me the whole updated spawn seed. Let's try it. Because if we can get this to work with the camera, that's like, um, it makes the next step, which is going to be building like a little flight model and things like that, it makes that a lot easier. Nope. It's still spawning with an offset. What was the other alternative suggestion? Oh, would it by any chance, yeah, this, would it not just be, gotta be a way? Okay, that's using last frame of reference. So if I use current frame of reference location. And then over here, I don't think we should actually need that. Like galaxy parallax ratio relative to universe. Yeah, okay. All right. Way over there. That was closer because we were going slower when it spawned. Okay, there's a frame delay. There is a frame delay on the camera fetch that doesn't appear to be there for the actor fetch. Yeah, that's it for sure. Because, like, okay, go away, we despawn it. We slowed down a lot. Trying to trigger a load here. Yeah, and if we're going slower, it spawns closer. Okay. Okay, looks like maybe there is a frame delay on the current method of changing the cam position. I noticed that if I approach slower, there is less of an offset. If I go faster, that makes me think that fetch cam is has some delay there fetching actor pause. Um, so basically, way Okay, a couple of these are interesting. So, and we're just like, get player viewpoint. We tried this though. Okay, so down here in tick. We're just gonna do this and this. Get rid of this. Copy this. Go over to Galaxy Actor. Paste this. Add the reference. Okay, let's try that. Oh no. That would do it. Let's put it back up. Player, camera, positions. Keep player camera positions. Position with no delay. UE5. Camera manager. Okay, yeah, it's not working right now. And then universe actor needs the same thing, right? Okay. Moving again. Great. Spawn a galaxy and see. Come on. Work, you fucker. It was close. It was close. Hmm.
This. Don't need this anymore, maybe. Don't need this anymore. This. And then likewise, these can go away. Okay, save it. So what did my spawned galaxy logic look like before? Uh, I'm never succeeding with that. So we need to update. I work in the morning, but I really wanted to get this done, and it's a puzzle. Going so slow. Okay, we're back. Now, breakpoint. Okay. Camera comp. Get you. We'll try that in a second. Okay, this is what the universe is doing. This is what the galaxy is doing. They should both work the same. Go and continue. So interesting. Like it's close, and it's actually kind of useful in that we can see how it's affected. All right, let's go a little slower. Yeah, so I'm almost certain there's like a frame delta thing going on. Um, and what we just did not fix it. Let's see what things we can do off of this component here. Okay, let's just do this.
Universe actor, galaxy actor. Try the other variant. Annoying. So we may have to explicitly save where our camera is, like in the character component or something. And like this is important, but it's really the universe actor. So here's what's kind of weird. I have been using flying. I move, made, not moved camera. Do that. Well, use
Camera to update position. We get this offset curve. We parented cam some other objects and used that for instead. So like instead of camera Wait, will that work? Because like that would be ideal if we could just like force the camera update immediately and then immediately read the position. That might fix it. Nope, it's even worse. Okay. Would we be able to get the camera indirectly from camera room it's already attached to? Variant reference location. Incorrect. Does the orientation change depending on my approach? Is it always on the is it always z-axis offset? The fuck? No, there's a variance. All right, keep trying. We'll find a way. Let's make sure they're both on the same paradigm, too. It, it appears to always be a similar offset. So, just out of curiosity, if I move the camera to here instead, see, but like that's still an issue. It means that we would need some form of an offset, a local offset to. But I do want to see this because, like, it was always spawning up, which would be expected if this was off center on the down axis, perhaps. So let's find out what happens when we center it. And then we would have to figure out, like, how to calculate that offset once we actually start moving the camera, right? Oops. Okay. That's it. That's it. So, like, there's an offset. But for now, you know what? Good enough. For now. I'm sure if we were to take this camera boom and, for example, increase the arm length, is something that would be like spaceship appropriate. The good news is that what we have right now would work just fine if it's a um, if it's first person. Like if you're in the cockpit of the ship you're flying, then yeah, we can like arbitrarily set the position the parallax occurs from to just be directly where your camera's at. Um, the bad news is if we want to do third person, we need that swing arm logic to work. And yeah, we have an offset. Um, but we might be able to calculate that offset. So let's think about what we needed to do to the actual camera position. So we will get rid of this. We had to offset the camera position to match the capsule component position. So it had to be centered on the root. So we need some, like, we basically needed to add the difference of where the camera is to the origin. Hmm, very interesting. All right, well, we'll have to do more work, but at least this fixes the issue. We're loading it from the camera or from the spring arm. I bet we could use the camera location. Um, okay, so maybe it wasn't the a delay offset needed. If I put the camera dead center on the capsule, on it works fine. If I put the camera at the bottom of the capsule, there's a vertical offset bending on roach speed at the top of the capsule. Oh, that goes down on the z-axis, etc. We may need to calculate the from the camera. Factor. Yes, that just using the anyway. Hmm. effective parallax position. What? But you don't use it again. Hang on. Current frame of reference. Universe actor. Spawn galaxy. Player, player, camera manager, get cam, location. This is going to be the same. It's fundamentally a different problem. Universe actor. Location. Location. Position. Location. what if we keep track of both using camera position, calculate let's offsets, but we could also track the pawn actor in each frame. Perhaps use that when spawning. Not sure. And then in Spawn Galaxy, player location. This. And let's try that. So we do have the spring arm right now. Okay. We're gonna need to pull this down because we need a spring arm to have an offset to be able to tell the difference. So let's grab the camera boom, add a target arm length of, I don't know, 400. Compile, save. Wait on this to finish and test. If if using both works, then that would be fine. This is a pretty simple solution. If it does work. I need to go to sleep. Fuck. Fuck me. God damn it. I think we're just gonna have to use player location. Okay, that's what we're gonna do. So, down here, as long as we make our domain big enough, then it shouldn't matter that it's based on our actor location. It just has to be like our extent of our universe and galaxies have to be big enough to where like the camera rotating isn't a big enough difference in motion to matter. Um, and I think they probably are already. Okay, let's try this. Current frame of reference is actor location, and then universe actor, we have to change a little bit. Frame of reference. Let's try it. Hopefully it just works. Okay. Spawn overlap works. I don't think I'm seeing enough shifting for the spring arm to matter. Let's get in like a position where it might. I'm not seeing much shifting around going on. I think we're good. We just have to have these be big enough. That's it. We make these big enough, and it doesn't matter that we're basing it off the actor location. And the actor location is static, so it's actually good. And honestly, it doesn't. I guess it doesn't matter really. The camera. The only thing is like if our spring arm was really long, it would matter. But I think with like we have a little bit of a grace area with our spring arm actually. Okay. I'm satisfied with that. I'm satisfied with that. So, um, we can go ahead and reduce our spring arm back. This means that we've got at least 400, like, this would be 4 meters worth of spring arm. I think we could probably get up to 10 or 20 meters with how big our octrees are. Uh, 0, compile, compile. This is gonna trigger me. We're just gonna do 90 since we know it doesn't really matter with the way we're calculating it now. So these are great, and like the nice thing here is that we made it so that we don't have to track our position externally. So that actually saves some time in the proximity tracker for galaxies. We just call add and then spawn the galaxy. All right. Okay, well, I'm actually pretty satisfied with that. It's not completely perfect, but like basically you think of it like this: um the bigger your like universe of shit is, the bigger your point clouds in real world space, not virtual coordinate space, the more leeway you have with like spring arm lengths and stuff. At some point, your spring arm length would be too long when you rotate the camera because those the particles are not actually miles apart. They're actually centimeters apart. You rotate the camera and then you would um, basically see visible shifting uh, like relative to the camera orbiting the center point. But like our octrees are so big that I don't think it matters that much. So better to just go for accuracy and positioning than like accuracy in perfect camera handling. right, so galaxy actor tracks parallax like this. And universe is the same. Everything is based off of the current frame of reference location now, so we don't have to feed extra information into spawn galaxy, just the node it should be spawned from, which is super nice. Okay, looks good. Get all this fucking dead code. Parallax ratio. Oh yeah, okay. Like so basically if we have a universe, we use the speed scale inherited from the universe so that everybody, like every galaxy, just automatically um, generates. Every galaxy like inherits the speed scale from the parent. Even watching this video, I like this guy's channel deck. Could run Ulamog too. I'm gonna make this timeless deck. This guy has got a fucking banger, I think. Scheming Symmetry, turn 1, get channel, turn 2, cast Emrakul, take an extra turn, swing, annihilate 6 permanents. Let's go ahead and commit these changes. I feel like we've hit a new baseline this weekend. I'm pretty pleased with the progress. Uh-huh. Updates, code cleanup.
Make sure everything still builds after that merge. That would suck if we broke it with a merge because those can be messy. But it looks like it's gonna work. Hopefully. Okay, so far so good. Start it up, make sure it works. Still works. On a galaxy, make sure it works. This is on master branch. Yep, we're good. New master. Commit. New baseline. Hell yeah. Good shit. Okay. I think that's gonna be it for tonight. I gotta work in the morning and probably already stayed up later than I should have. So yeah, later.